everybody? Welcome to another video. Hope you're ready to flex those brain muscles. Today we're going to do some more examples with solving linear equations. This is a continuation of the last video. You can click up there if you have not seen that video. Let's go ahead and get right into it. We'll do some more examples. So, first example, 2t minus 6 equals 3 minus t. And this is a little different than the examples we've seen so far just because we see t show up in two different places. Our variable is on both sides of the equation. But it's actually not a huge deal. It's an easy fix, right? Because anything with just t, for example, and being added and subtracted, these are all like terms. Anything with t, 2t minus 10t plus 5t minus 3t, all these things can always be combined, right? They're like terms. So that's what you're normally going to want to do when you see the same variable in two different places. You're going to want to get everything with t on one side and everything else on the other side, and then it becomes a lot simpler. So I'm going to go ahead and add t to both sides, plus t. So that gets rid of this minus t. And then what happens? 2t plus t. That's actually 3t. So I'm left with 3t minus 6 equals 3. And all I need to do is get the 3t by itself. So I can add 6 to both sides. Right? Because I'm trying to isolate t. I'm trying to solve for t. So let's see, plus 6 minus 6, that cancels. 3 plus 6, that's 9, so 3t equals 9. Now, how do I get this t by itself? It's being multiplied by 3, so I divide by 3. I got to get rid of that 3. So divide both sides by 3, and I get, let me draw a little arrow here, I get t equals 3. Okay, so in general, when you see the same variable, and we'll look at this example too, we have x on both sides. Get everything with x on one side and combine all the like terms. Get all the constants, get everything else on the other, and then you just solve for x. You divide or multiply, whatever you got to do to get x by itself on one side. So let's go ahead and solve for x here. I can add x to both sides. I have plus x, and that leaves me with, that gets rid of this and leaves me with 6x plus 6 on the left-hand side. And that equals 18 on the right-hand side. So I got a couple more steps. I got to get this 6x by itself, so I got to get rid of that plus 6. I can minus 6 to both sides. So subtract 6 from both sides. Plus 6 minus 6, those cancel. I'm left with 6x equals what? 18 minus 6, that's 12. 6x equals 12. Now I can divide both sides by 6 so I can solve for x. I gotta isolate x, it's being multiplied by 6, so to get rid of that multiplication, I have to divide by 6. So divide both sides by 6, and I'm left with x equals 2. Alright, let's mix things up a little. We'll throw a bunch of fractions in here. So don't panic, it's the exact same process. So 1/3 x equals 2 minus 4/3 x. So again, I see x show up on both sides. I'm going to move everything with x's. In this case, I'm going to go ahead and move to the left-hand side, and everything else is going to go to the right-hand side. So let's go ahead and do it. I'm going to add 4/3 x to both sides, plus 4/3 x plus 4/3 x. Alright, so that cancels. Minus 4/3 x plus 4/3 x, that cancels. And I have 1/3 plus 4/3, and luckily I already have the same denominator, so I can just add the numerators. That's 5/3 x. So I'm left with, I'll write this over here, 5/3 times x, right? 5/3 x equals 2. So now how do I isolate my x? You can do this in 2 steps. You can multiply both sides by 3 and then divide both sides by 5. But basically what you're doing is you're multiplying both sides by the reciprocal of this number in front of the x. That's what you're always going to do. When there's a fraction like this in front of the x, you multiply both sides by the reciprocal, and that's how you can cancel that fraction. So look what happens if I multiply by 3/5 both sides. Then these 3's cancel each other, these 5's cancel each other. This actually cancels to become 1, right? And I'm just left with x. 1 times x is just x. This equals 2 times 3/5. How do I multiply these? Well, remember, 2 is just 2/1. So this is really 2 over 1 times 3 over 5. And to multiply fractions, I just multiply across. So that's 6 over 5. And that's exactly what I get for x, 6 over 5. Alright, this next example, I have 1/2 plus 2 over x equals 5 over 4. So in this case, I only have x showing up once in my equation. But it's in a denominator, and we haven't seen this yet, so we'll learn how to deal with this. But it's the same process for now. I'm going to just try to keep this here. I'm going to move this 1/2 over, basically. So 1/2, I'm going to subtract 1/2 to both sides. Minus 1/2 to both sides, minus 1/2. So that means these are gone, that cancels. I'm left with 2 over x on the left-hand side. Alright, how do I do this? I got to get a common denominator, right? And in this case, my common denominator is actually 4. I can multiply this by 2 over 2. So if I multiply 1/2 by 2 over 2, oops, threw my eraser, sorry. 1/2 by 2 over 2, I get 2 over 4. And I get 5 minus 2 is 3 over 4. And that's what I'm left with just on the right-hand side of the equation, so 3 over 4. Okay, so how do I deal with this? Well, there's a little trick you can use, and it's called cross multiplication, right? You can cross multiply. And if you don't know this trick, basically draw an X across, right, like this. And you can rewrite this as 2 times 4 equals 3 times x, right? And the reason why this works, this is just a shortcut, because all you're really doing is you're multiplying both sides by x and multiplying both sides by 4. You know, and this is just a shortcut for how it happens to work out when you do that. This cross multiply thing only works when you have one fraction on both sides of the equals, right? But yeah, go ahead and cross multiply. 2 times 4, that gives me 8. And 3 times x, that's 3x. So now I just need to isolate x. So it's being multiplied by 3. That means I need to divide by 3. So I divide both sides by 3. And my final answer is x equals 8 over 3. Alright, last 2 examples. So with this example, we have some parentheses. And it would be to our advantage to expand this, to basically distribute this 3 out into those parentheses. And remember, what we do to one side, we have to do to the other. So like add, subtract, multiply, divide. If I do that to one side, I have to do that to the other. With parentheses and stuff and expanding, and you don't have to worry about that, because all I'm doing is I'm rewriting the left side of the equation as something that's equivalent to what it already is. So I'm not changing it in any way. So I don't have to do anything to the right side. So don't worry about that. So I'm going to go ahead and do this. 3 times 2 is 6. And then 3 times x is 3x, so minus 3x. And it's almost always to your advantage when you're solving these linear equations. I think it pretty much always is to get rid of parentheses and like expand everything out. So this equals what? 2x minus 1. Now it's just pretty straightforward. I get all the x's on one side, everything else on the other side. So I'm going to add 1 to both sides. Plus 1 plus 1. That gets rid of this minus 1. And I'm left with, I'm going to go over here. I'm left with 2x on the right side. Here on the right side. On the left side, what am I left with? 6 plus 1 is 7. Minus 3x. I got a couple more steps here. I got to move this 3x to this right side. I'm going to add 3x to both sides. Now I'm left with what? 7, right? Because these minus 3x plus 3x canceled. I'm left with 7 equals 2x plus 3x is 5x. Now I got one more step. I need to solve for x. X is being multiplied by 5, so I got to divide by 5. Both sides by 5. And I'm left with x equals, let's see, those 5's cancel, 7 over 5. 7 over 5. There we go. All right, last example. 3 over 2x equals 4 minus 2 over x. All right, we got x on both sides, and it's in the denominator in this case. So let's go ahead and get everything with x on one side. So I'm actually going to add this plus 2 over x to both sides. So I'm left with 3 over 2x plus 2 over x. Sorry about that. Plus 2 over x equals 4. Now I need to add these. So I need a common denominator. What can my common denominator be? It's a little tricky because I have x's, but in this case it's actually just going to be 2x, right? What if I multiply by this by 2 over 2? Right? Both these denominators share a common factor of x. All that's missing is the 2. So this guy just needs a 2. I'm going to multiply this by 2 over 2, and I get 4 over 2x. So I'm just going to rewrite it here. 4 over 2x. 4 over 2x. Okay, now what? Now I can just add. 3 plus 4 is 7. So that's 7 over 2x when I combine them. I'll rewrite this over here. 7 over 2x, yeah, equals 4. Okay, so now what can I do? I can still cross multiply. Even though there's not fractions on both sides, I can make this 4 into a fraction, right? I can rewrite the 4 as 4 over 1, and then I can cross multiply, if that's how you want to do it. Your cross multiplying is the best way, I think. It's a shortcut that everyone uses for a reason, because it is a shortcut. 8x equals 7, that's what I get. 2x times 4 equals 8x. And 7 times 1 equals 7. And now I just divide both sides by 8 to isolate the x. X equals 7 over 8. Alright, hopefully this helped. If it did, make sure to hit the like button, hit subscribe, leave any questions you may have below, any suggestions, that sort of thing. Go to my channel, check out my videos if you enjoyed. Maybe you can get some more help there. And until next time, keep flexing those brain muscles, keep making those brain gains. See you later.